we are going to learn about special right triangles. But before we do that, please look at the Pythagorean theorem video linked below if you are not familiar with what the Pythagorean theorem is. Now let's say I have a square. And the definition of a square is that all four angles are 90 degrees, and all the sides are equal. All the sides are the same length. So I'm going to put 90-degree angles or right angles on all four angles. And since all four side lengths are the same, I'm going to label all the side lengths x. Now let's say I draw a line from here to here that divides the 90 degrees into half. Now I'm only going to look at this triangle. So we have a triangle here with the legs being the same length, which I labeled as x. And we have a right angle here. And since I said that I drew a line that divides the 90 degrees into half, this angle is going to be 45 degrees. And this angle is also going to be 45 degrees. Now, what is the hypotenuse? Well, the Pythagorean theorem says c squared equals a squared plus b squared, where c is the hypotenuse and a and b are the legs of the triangle. We are given the legs of the triangle, which are x and x, so we can plug that in the formula to solve for the hypotenuse. We will get c squared equals x squared plus x squared. We will get c squared equals 2x squared. When we square root both sides to solve for c, we will get c equals the square root of 2 times x squared, which is simply the square root of 2 times x, hence x root 2. Now, let's notice the ratios. Let's take note of the leg to hypotenuse ratio in this particular triangle. The leg is x, the other leg is x, and the hypotenuse that we just found is root 2 times x. So we can write this ratio as x to root 2. This is the ratio of this particular triangle. And this kind of special triangle is called a 45-45-90 triangle because there are two 45 degrees and one 90-degree angle in this triangle. This ratio x to x root 2 only works with triangles that have degrees 45, 45, and 90. Keeping that in mind, let's do some practice problems. What is the hypotenuse of a 45, 45, 90 triangle with the leg 2? In this problem, they only gave us one leg, which is 2. However, because it is a 45, 45, 90 triangle, you know that the other leg is the exact same, which is 2. So let's draw a picture. We have a right triangle with two 45-degree angles, and the legs are 2. Now let's write a ratio. The ratio is x to x root 2 for 45, 45, 90 triangles, where x's are the legs and x root 2 is the hypotenuse. In this case, we have 2 to some missing number. So we will look at one of the leg ratios. So we have x to x root 2, and we have 2 to some missing number. This shows that x is 2. And since x is 2, x root 2 equals 2 root 2, which is the hypotenuse. You can check your work by using the Pythagorean theorem. C squared equals a squared plus b squared. We found c, which is 2 root 2, and we are given a and b in the problem, which are 2 and 2. We have 2 root 2 squared equals 2 squared plus 2 squared. 2 root 2 squared is 8, and 2 squared is 4, and 2 squared is 4. 4 plus 4 is 8, so 8 equals 8. Therefore, 2 root 2 is the correct answer. Let's try another example. What is the hypotenuse of a right triangle with the legs of 5 and 5? In this problem, they gave us 2 legs, which are 5 and 5. However, you might be wondering we can't use the ratio x to x root 2 in this problem because it doesn't specify that it's a 45, 45, 90 triangle. This is something to keep in mind. When the legs of a right triangle are the same, it is a 45, 45, 90 triangle. Since the legs, which are 5 and 5 in this problem, are the same, we know that it is a 45, 45, 90 triangle. So let's draw a picture. So we have this right triangle with 45 degrees here and 45 degrees here. The legs are 5. So we have the ratio x to x root 2. In this problem, the ratio will be written as 5 to some unknown number we are trying to solve for. We will look at just this part. X to x root 2 and 5 to some unknown number. We know x is 5, and since part of the ratio is x root 2, we know the length of the hypotenuse is 5 root 2. The pattern for finding the hypotenuse of a 45, 45, 90 triangle is just the leg times root 2. So the hypotenuse is 5 root 2. Let's try another example. What is the hypotenuse of a right triangle with the legs of 6 and 7? In this problem, they gave us 2 legs, which are 6 and 7. However, we cannot use the 45, 45, 90 triangle properties. We cannot use that ratio because the legs are different numbers. Since the legs are different numbers, we know it is not a 45, 45, 90 triangle. For a triangle to be a 45, 45, 90 triangle, the legs must be equal to each other. Since the legs are not the same number, this is not a 45, 45, 90 triangle. However, since it is a right triangle, we can use the Pythagorean theorem to solve for the hypotenuse. So let's draw a picture. We have a right triangle, and we don't know what the angles for the other 2 are. We just know that they're not 45 degrees, since the side lengths are not the same. But we know the legs are 6 and 7. So for solving the problem, we have c squared equals a squared plus b squared. Since a and b are the legs, we will get c squared equals 6 squared plus 7 squared. C squared equals 36 plus 49. C squared equals 85. And C equals the square root of 85. Therefore, the hypotenuse is the square root of 85. I threw this problem in so that you realize in what case you can use the ratio x to x root 2. This case is not one of them. Let's try another example. What is the third side of a right triangle with the leg of 8 and a hypotenuse of 8 root 2? In this problem, they gave us a leg and a hypotenuse. Since the right triangle has 2 legs and 1 hypotenuse, we know that we are finding the other leg. Now, is this problem a 45, 45, 90 problem? The answer is yes. This is a 45, 45, 90 problem because the hypotenuse is the leg times root 2. The leg is 8 and the hypotenuse is 8 root 2. So let's draw a picture. We have a right triangle with two 45-degree angles, and we have a leg, which is 8, and the hypotenuse, which is 8 root 2. So the ratio for a 45, 45, 90 triangle is x to x to x root 2. This right triangle has a ratio of 8 to x to 8 root 2. I'm going to look at the two leg ratios, x to x and 8 to x. Since x equals 8, the other leg equals 8 as well. Hence, since the legs of a 45, 45, 90 triangle equal each other, we know that the other leg equals 8. Let's try another example. What is the third side of a right triangle with a leg of 4 root 2 and a hypotenuse of 8? In this problem, they gave us a leg and a hypotenuse. Since a right triangle has 2 legs and 1 hypotenuse, we know that we are finding another leg. Now, is this problem a 45, 45, 90 problem? Don't let the 4 root 2 leg confuse you. In the end, a 45, 45, 90 triangle just says that the legs are the same and the hypotenuse is equal to the leg times root 2. So let's see if it's a 45, 45, 90 triangle. So we will multiply 4 root 2 times root 2, and we get 8, which is the hypotenuse. Therefore, this is a 45, 45, 90 triangle. So let's draw a picture. We have a right triangle with two angles being 45 degrees, and we have a leg, which is 4 root 2, and we have an hypotenuse, which is 8. We are trying to solve for this leg. The ratio for a 45, 45, 90 triangle is x to x to x root 2. The ratio for this problem is 4 root 2 to some unknown number to 8. We will look at the two legs, x to x and 4 root 2 to x. Since x equals 4 root 2, the other leg equals 4 root 2. We know in a 45, 45, 90 triangle that the legs of the triangle are the same. Therefore, the missing leg is 4 root 2. The answer is 4 root 2. Now, let's look at a different kind of special right triangle. This is called the 30, 60, 90 triangle. And just how the 45, 45, 90 triangle was named off of the degrees in the triangle, a 30, 60, 90 triangle is also named off of the degrees the triangle has. So I'm going to draw a picture. This is a triangle and it has a right angle or a 90-degree angle over here. The angle opposite the shorter leg is 30 degrees, and the angle opposite the longer leg is 60 degrees. This says that the leg opposite the 30-degree angle is x. The leg opposite the 60-degree angle is x root 3, and the hypotenuse, which by definition is opposite the right angle, is 2x. So we can write the ratio of a 30, 60, 90 triangle as x to x root 3 to 2x. X is the shorter leg, x root 3 is the longer leg, and 2x is the hypotenuse. So let's do some practice problems. What is the hypotenuse of a 30, 60, 90 triangle with the shorter leg of 2? In this problem, they only gave us one leg, which is 2. However, they specified that the shorter leg is 2, meaning that this is the leg opposite the 30-degree angle. So let's draw a picture. So here we have a right angle, and the angle opposite the shorter leg is 30 degrees, and the angle opposite the larger leg is 60 degrees. The leg opposite the 30-degree angle in this case is 2. This is the information we have so far. Now, we can use the ratios of 30, 60, 90 triangles in this problem. The ratio is x to x root 3 to 2x. The ratio here is 2 to some number to some number. The problem is asking for the hypotenuse, so we will focus on two ratios, the shorter leg and the hypotenuse. We will focus on x to 2x and 2 to some number. X equals 2, so if you substitute x equals 2 inside 2x, you will get x equals 4. Another way to think about this is the ratio between the shorter leg and the hypotenuse says to multiply the shorter leg by 2 to get the hypotenuse. Therefore, the hypotenuse equals 2 times 2, which equals 4. The hypotenuse in this 30, 60, 90 triangle is 4. Let's try another example. What is the larger leg of a 30, 60, 90 triangle with the hypotenuse of 6? In this problem, they only gave us the hypotenuse, which is 6. So let's draw a picture. Here we have a right triangle with the angle opposite the shorter leg being 30 degrees, and the angle opposite the longer leg being 60 degrees. The hypotenuse is 6. And we are trying to find this, the larger leg. So the ratio in a 30, 60, 90 triangle is x to x root 3 to 2x. The ratio in this problem we know of is some number to 6. Since we are given the hypotenuse and are trying to solve for the larger leg, we are only going to look at these ratios. X root 3 to 2x and some number to 6. So looking at just the hypotenuse ratios, 2x and 6x, we can equal them to each other. 2x equals 6. Therefore, x equals 3. When we plug 3 back into the ratio, we're going to get 3 root 3 to 6. 3 root 3 is the larger leg of this 30, 60, 90 triangle. Let's try another example. What is the shorter leg of a right triangle with the longer leg of 4 root 3 and a hypotenuse of 8? This problem doesn't specify that it is a 30, 60, 90 triangle. So let's see if it actually is one. The ratio of a 30, 60, 90 triangle is x to x root 3 to 2x. Let's look at the ratios of the longer leg and the hypotenuse, since those are the ones we are given in this problem. X root 3 to 2x. In this problem, the ratio is 4 root 3 to 8. When we set the two hypotenuses equal to each other, we get 2x equals 8, and therefore x equals 4. Therefore, in the top we will get 4 root 3 to 8, which is the same ratio as the problem says. Therefore, this is a 30, 60, 90 triangle. So let's draw a picture. Here we have a right triangle, and we have 30 degrees that is opposite the shorter leg, and 60 degrees that is opposite the longer leg. The longer leg is 4 root 3, and the hypotenuse is 8. So this is what we have so far, and we are trying to solve for the shorter leg. So let's use the ratio x to x root 3 to 2x. This is the ratio of the shorter leg to the longer leg to the hypotenuse. In the context of this problem, the ratio is some number to 4 root 3 to 2x. You can use the shorter leg and longer leg ratio or the shorter leg and the hypotenuse ratio to solve this problem. I will use the shorter leg and the longer leg ratio. So we have x to x root 3 and some number to 4 root 3. So if we set the longer leg ratios equal to each other, we get x root 3 equals 4 root 3. When you divide both sides by root 3, you will get x equals 4. So we substitute x to x root 3 with x being 4 and get 4 to 4 root 3. Therefore, the shorter leg of this 30, 60, 90 triangle equals 4.